All right, now we're starting to look at actual Algebra 1 content. So if you remember the quiz that we took last week, all the stuff that we're going to cover in this video and probably the next one, I don't know how many of these I'm going to make, but still, I'm just going to talk about some of those things that we saw on the quiz little by little, all right? Starting with number classification. Okay, so number classification, basically, you saw this as either, rational, integers, whole numbers, natural numbers. Well, let's define what all of those are, shall we? So let's start with the most basic number, natural numbers. Now, these stem from, a time long ago when numbers weren't even really a thing. Way back when cavemen or whoever had like sheep or some cattle or whatever, they didn't actually count them. They would have a stone set aside for each sheep that they had. So if they had 5 sheep, they would have 5 stones out, next to it. And so they would have each stone for 1 sheep. That's how they'd keep track. That's how they would know if 1 sheep ever ran away or whatnot. They wouldn't just count how many there were. 5 wasn't a number to them. They just kept sort of a mark of them, okay, via a stone. But natural numbers are where this all begins because these are the counting numbers. Counting numbers, 1, 2, 3, 4, 5, and so on, okay? We broaden our horizons towards whole numbers. Whole numbers are all of those counting numbers, so keep in mind, 1, 2, 3, 4, those are whole numbers, but we introduce 0 in this group. So 0 is all of those numbers from natural numbers, but as including 0. Next, broaden it a little bit more, we get integers. Integers are all those numbers we just mentioned, 0, 1, 2, 3, 4, and so on. And their opposites, their negative versions of them. So -1, -2, -3, -4, right? All of those are integers as well as the 0, 1, 2, 3, and 4. And then rational numbers. Rational numbers kind of fill in the gaps here because we haven't talked about anything like fractions or decimals yet. Rational numbers introduce that category to us. So fractions, decimals that end or repeat are rational numbers, okay? So there's one big umbrella of numbers. Keep in mind, 1 is a natural number, 1 is a whole number, 1 is an integer, and 1 is also rational. So the number 1 is all 4 categories that we have up there. So it is one of those things where certain numbers are going to be in more than one category. And a completely separate or side category are the irrational numbers. So these are all the numbers that we haven't, don't fill in fill in the rest of the gaps, I should say. Irrational numbers are nonsensical numbers. They're numbers that have decimals that go on forever. They don't repeat. They have no pattern. They're just a bunch of random numbers going on and on and on. Okay? For instance, pi, 3.141592 something, whatever. It goes on forever. There's no pattern or any of that. Square root of 2 does the same thing. So there's a difference between decimals that are rational and decimals that are irrational. Because decimals that are rational, they can go on forever, but if they do, they have to have a pattern, like 333 or 919191. Irrational numbers will go on forever, but with no pattern. Okay, so keep in mind the difference there. So let me show you a little picture, help illustrate this idea. So again, you have 2 umbrella categories. You have the rational category, all that, and you have the irrational category. So a number is going to be either one or the other of those. There's not a number that's both rational and irrational. There's not a number that's neither rational or irrational. Well, at least in the real number world, there isn't. Okay, so it's either going to be rational or it can be irrational. It's just the catch is, if it's rational, sometimes it can also be an integer, a whole number, or even a natural number. Okay, irrational numbers though, if they're irrational, they are just irrational. None of the other categories would apply. Okay? But every number that you look at will be either rational or irrational. So I think from our quiz, there is a number -4/5. -4/5, its category would be rational. And just rational, right? It's not integer because fractions are not integers, okay? Or any of those other ones either. Fractions are only in the irrational section. Another one from our quiz, I think, was 24/6. Now, 24/6, this is a disguised number. It's kind of a trick question because this number is really the number 4, just dressed up funny. And the number 4 is a natural number. Thus, it's also, as you can see, a whole number, right? It's also an integer, and it's also rational. So it's all 4 of those categories: natural, whole, integer, and rational. Okay. The square root of 5. Square root of 5 is irrational. If you use a calculator, kind of cheat a little bit, you get a long decimal, 2 point something, something, something. It goes on forever, no pattern to it at all. So it's irrational. All right, and our last one, 0. The number 0, as you can see, 0 is not a natural number, but it's a whole number, it's an integer, and it's a rational as well. So keep that in mind. All right, moving quickly along to solving equations. So what I'm going to do is I'm going to skip ahead a bit. I'll show you all of these, and then we'll move on. So what I did here was I started really basic, simple one-step equations like this, move our way up to two-step equations, and then something a little bit more elaborate. I'm not going to solve these or go over them with you. I'll just leave them here because I think for the most part, we generally know how to do this. If you're unsure how to do these problems, then you should come by to tutoring or something after school so we can get you caught up a little bit on that. All right? But I did this because the questions on your quiz were basically the same as these, but more complex in the sense that there's just more layers to it. It's all the same math, but it's just more of it. So my point was, if you can do this stuff, you can do the questions like we saw on the quiz. Okay? Even this one, I'll go ahead and skip ahead a bit. So now let's look at one from the quiz. All right, and I'll work this one out with you. So this is number 5, I think, from the quiz. So the first thing we need to do, we should simplify what we have, which means distribute both of these so I can kind of get rid of the parentheses. So that means 3 times 2x is 6x, 3 times 4 is 12. So that's the left side. And 2 times 4x is 8x, and 2 times -1 is -2. That's the right side. All right, so now it's a regular, pretty much normal equation. It's kind of like the one you just saw here on the left. But here, I'll finish the problem for you. My general philosophy, because there's a couple things you could do here in terms of what you do first, but my general philosophy is to take the x terms and combine them. Now, the problem is I have an x term on the left and I have an x term on the right. So if I were to combine them, I either need to move the 6x from the left side to the right side, or I can move the 8x from the right side to the left side. It's not going to matter which one I move. However, to make things easier, it's better if you move the smaller x term, or the smaller number. So in that case, the 6x. So I'm going to move the 6x over. So it's a positive 6x. I'm going to get rid of it by subtracting the 6x, which means on the left side it'll be gone. I'll just have 12. 8 minus 6 will be 2x, and then minus 2. And what I'm going for there is I just want to make sure when I combine my x terms that I don't get a negative result. I can deal with it if it's negative, but if it's not negative, it's just going to make things a little bit easier for us in the rest of the problem. Okay? So that's my goal. I'd like to avoid negatives. If I subtracted 8x instead on this side, I would have gotten negative 2x, which is fine, but it just means I have to worry about negatives, and I don't want to worry about negatives. So if you finish this problem off, you'll add 2 to both sides. We'll have 14 equal to 2x, and you can divide by 2, you'll get x equal to 7. All right. So if you care to pause the screen so you can see them, you can. I'm going to move on. All right, solving equations. This is another one from our test. very similar to the last one. Start by distributing. Go ahead and take care of these parentheses. This gives us 6x minus 15. And now here's something to be careful of. Read that as a -2 and distribute the negative as well. So -2 times x is -2x. -2 times -4 is +8. So be very careful about distributing that negative. At this point, there's still a lot going on with the left-hand side, but we can combine some like terms. 6x minus 2x is 4x. And I also have -15 and +8. That can be combined. -15 plus 8 is -7, so that'll be -7. All right, so similar to the problem before, I got to move the x terms over. You can either move the 4x to the right side or the 3x to the left. I'm going to move the 3x to the left because then I won't have any negative numbers, right? That's going to go away, and 4 minus 3 will just be 1x. So have -7 still, we have -1 still. So add 7 to both sides, we'll get x equal to 6. Okay? All right. So just to save a little time, I'm going to end the video here, and I'll start a new one with this category of this stuff here, the evaluating the expressions and absolute value stuff. So if you're interested in seeing those, then click the next link. Otherwise, I'll stop it here. Okay? See you guys later. Have a good one. Bye-bye.